Electrical knowledge is critical for utility arborists because trees and electrical systems share the same space, and misunderstandings about electricity can be fatal. Arborists are not expected to design or repair electrical systems, but they must understand how electricity behaves, how power systems are constructed, and how vegetation can interfere with those systems. This knowledge supports safer decision-making, better communication with utility personnel, and more effective vegetation management practices. At its most basic level, electricity is the movement of electrons through a conductor. For electricity to flow, there must be a source, a path, and a load. Voltage is the pressure that pushes electrical current. Current is the flow of electricity, and resistance is what limits that flow. Electricity always seeks a path to ground, and it will take all available paths, not just the one we expect. This is why electricity can travel through trees, tools, ropes, and even the human body if conditions allow. Contact is not required for injury to occur because electricity can arc through the air when voltage is high enough. Understanding how electricity travels from the power source to the end user helps arborists recognize where hazards exist. Electricity is generated at power plants and transmitted over long distances at high voltages to reduce energy loss. These transmission lines carry extremely high voltage and require large clearances. Power is then stepped down at substations to lower voltages suitable for distribution systems. Distribution lines deliver electricity to neighborhoods and businesses. And finally, transformers reduce voltage further before it enters buildings as usable household current. Each stage of this system presents different hazards, and arborists must recognize whether they are working near transmission, distribution, or secondary service lines, because clearance requirements and work methods vary. Electrical hardware is another important part of this understanding. Poles, crossarms, insulators, conductors, transformers, switches, and protection devices all serve specific functions within the electrical system. Insulators are designed to prevent current from flowing into poles or structures, but they can become compromised by contamination, damage, or moisture. Conductors may be bare or covered, but covered conductors are not considered insulated for worker protection unless specifically rated and verified. Transformers store and regulate energy and can remain energized even when upstream lines appear de-energized. Arborists must never assume equipment is safe based on appearance alone. Trees are a leading cause of electrical service interruptions, especially in distribution systems. Branches contacting conductors can cause momentary faults, sustained outages, equipment damage, and fires. During storms, tree movement, broken limbs, or uprooted trees can bring lines down, creating extremely dangerous conditions. Even without direct contact, vegetation growing too close to conductors can allow electricity to arc, particularly in wet or windy conditions. Many outages attributed to weather are actually the result of vegetation that was already within strike distance of electrical facilities. Vegetation-related outages are not just reliability issues, they are safety issues. Downed lines can energize trees, fences, vehicles, and the ground itself, creating hazards for workers and the public. This is why proper clearance and proactive vegetation management are essential. Emergency response work following outages is far more dangerous than planned maintenance, which is why utilities prioritize systematic vegetation management programs. Vegetation management regulations exist to address these risks. OSHA regulations govern worker safety and define training, qualification, and work practice requirements. ANSI Z133 establishes safety standards specific to arboricultural operations, including line clearance tree work. The National Electrical Safety Code sets minimum clearance distances and construction standards for electrical supply and communication lines. In addition, utilities may have internal standards that exceed regulatory minimums. Arborists must understand that these regulations are interconnected and that compliance is not optional. When multiple standards apply, the most protective requirement must be followed. Electrical knowledge also supports better communication between arborists and utility personnel. Understanding basic electrical terms, system components, and hazards allows arborists to coordinate work effectively, recognize abnormal conditions, and respond appropriately to changing situations. It also reinforces the importance of minimum approach distances, proper tool use, and maintaining situational awareness at all times. In summary, electrical knowledge is a foundational requirement for safe and effective utility arboriculture. Understanding how electricity behaves, how power moves from generation to end use, how electrical hardware functions, and how trees cause service interruptions allows arborists to manage vegetation responsibly and safely. Regulations exist to protect workers, the public, and the electrical system, and they rely on informed, disciplined decision-making in the field. When arborists respect electricity and understand its risks, they play a critical role in maintaining reliable service and preventing serious incidents.